Hello and welcome to another Unreal Engine 5 video. In this video we'll complete the jet setup and we'll make the final fixes and improvements and also add engine sounds and particle effects for the engine. First let's start by making the gear only close when we are in air. So let's go to our blueprint. Now we need a check that makes sure that we are in air. Unfortunately, we can't use the default function here, like flying uh, or the falling. Because when we are in air, it doesn't change uh, these functions. It doesn't change the movement type for the blueprint. So we need to make our own function to check for the altitude and make sure that we are above the ground so we can close or open our gear. So let's make a new function, call it check altitude. In this function we need line trace by channel. The line trace starts from the actor location and we wanted to point downward plus minus 2000, or you can use, instead of plus, you can use minus and only 2000. You can use any one of these, plus or minus. And here break the hit result. We need to check if it is a blocking hit, if it hits the ground or not. And if it hits the ground, we check the distance. First need to clamp the distance between 0 and 2000 and promote to a variable, call it I already have a variable made. Oh sorry, let's delete it. I already made a function, so I'll also delete it. Now we have this variable, we set the distance. Also, if it does not hit, we need to make it if the line trace does not hit anything, so it means we are above the 2000 level, 2000 units. So we need to make it if it is 0, or if we are above the 2000 value, the distance will be 0, and this will give us problems that if we are in air and above the 2000 level, when it gives us 0, we cannot open or close our gear. So if we are above 2000, we need to set the distance to 2000. I hope you understood what I mean. So if the line trace does not hit anything, does not hit the ground, which it means that we are above the 2000 level. So set it to 2000, because if we do not set it, it will go back to 0, and 0 which will mean that we are on the ground. So we need to add a return node and make an output, call it in air or flying, anything you want, you can name it. And here we need to check if the distance is in the range that we want, in range, or not in range. Let's make it above, greater than 500 units. We'll make it true. We need to connect the both executions lines to the return node. Now also we need to make this function sorry, my laptop is getting heavy. Now to make it pure function, we do not need the execution pins. Now let's go to the now we go to the let me delete this because the computer crashed. So we get the function and make a branch and let's check for the if the plane in air. Let's check if we now let's test. Let me just go to the level. Now let's test. If I press J, you see that it checks if I'm on the ground or not. It does not do anything. So let me fly and check. Yes, we can now elevate the gear, and if we press J again, sorry, I will fix this with this unrealistic maneuvers. Now let's check again. Now we can elevate the gear. Press again, can get down. Now can go up again. Now I will make the airplane accelerate smoothly, and also when it is in air we need to check or need to set the speed to a certain level, because if you release the throttle and it gets slow, it makes some unrealistic maneuver like what we saw before. Let me show you now. If you press the pitch up, it flips like this, and it's very unrealistic. So we need to make sure to keep the throttle at certain level to prevent these maneuvers. Now we need first let's make the thrust smooth by using the FinTurb node. FinTurb 2 will give a smooth transition from 0 to 1. You just make a place. Now need to split this away. Now we need to promote this to a variable, call it input axis, or thrust, or thrust value. Now connect these. We connect the execution pins here, and the target, make it the input axis value, and the current value will be our thrust. Just let me thrust value delta time get world delta seconds, and the interrupt speed, let me try 0.8. Let's see. Now we start slowly. Now let me just decrease it more, 0.5. Now let's limit the speed and make the vehicle does not go below a certain speed. What I will do is I will limit the thrust value and make it that when we do not press the thrust button, or we want to slow down, if we are in air above the 500 units, I will use the same check altitude node, I mean function. If we are still above this altitude, the vehicle, the thrust will be clamped to 0.5 or more. So let me just make place. Now here let's check for first check if sorry equal below. Let's check if the value here of the input axis below or equal to 0. We make place more. It is not, if it is more than 0. Now we go to the thrust, and let me bring this down here. Now we add another check, the check altitude branch. Check if we are above, we are in here above the 500 units, we set the throttle input to 0.5. Let's duplicate this and bring it here. Or instead of this, you can duplicate this here, make it smooth. We just organize this. I think we need more space. Now, if we are below the here, we want to first to clamp the value, clamp axis. Sorry, I mean clamp float. Clamp float. Minimum is 0.5 and the maximum is 1. Leave it as 1. Now, if we are, let me collapse this into a function. Collapse the function. Let me just organize this. Need only one. We delete this. Delete the output pins. This one. Vehicle component. Input. Axis. Refresh the node. Also this one. This function, call it, or you don't need to call it anything. Just delete this and we'll clamp the float before the let's return this. We will add here more input, maximum input, call it, and here minimum input. Make them to float. Sorry, maximum is here and the minimum is here. Need to okay. Just organize these. Let me reverse the name. Minimum is above, make it. And max, min, and max. We're making this function to so that we can use it in all the branch execution instead of making more. Let's call this set thrust input. Now let's go back here. Let's delete this. Now here, if we are above, we are flying, and we want to decrease the speed. We want to clamp the input to between 0.5 and 1. And let me duplicate this. Previously, if we are pressing the throttle, so this is the input access, put it here on the vehicle component, and the minimum will be 0 and the maximum will be 1. And we need this, duplicate it also. Here, if we are on the ground and we want to stop, the minimum will be 0 and maximum will be 1. Now let's check. First, let me make a tick and check the throttle values. Let's see. Now it's 0. Getting up to 1. Flying. Now we are flying, and let's try to make it decrease speed. It's not working. Let me check. Let me check here. Sorry. The thing is, we clamped after we set the value. It worked, but we couldn't see it in the print string. Just move the clamp before the thrust axis value. Now let's test. Now we are moving. My thrust value is getting increased gradually. Now if I leave the throttle, now it's clamped to 0.5, and if I press the slow down, also it's clamped to 0.5. And let's try the elevate the pitch, and it does not make the weird movements. And also we can leave the throttle and do not press it all the time we are flying, and it will maintain certain speed. Now I press the throttle, it's getting faster. Now you can change the value to your preference. Now I will add the sounds, the jet sound, and also the uh, particle system for the engine. Now the particle system and the sounds I will provide you in the description. Now let's add Niagara system. We need two, one for the right engine and the other for the left engine. Uh, let's see, what should I call it? Mm, Let me find it. Engine, F18, and the other one also engine. We need to. I already made two sockets for the engines, left and right. You add it here, add the socket, rename it, and set the position to the place that you want here. Now the engine, the right engine for the right engine, attach it, and the left engine, attach it to the left engine. Need to rotate them by 180 degree. 180 degree above the on the Z value. Now let me just make this scale to 1. Now let me just I think this is better. Now we also need to add sound, audio. Let's call it engine. Here I name it jet engine. Now we need to change the scale of the particle system when we press the throttle. We want it to get bigger, and when we release the throttle it will get smaller. So here we need the tick value. Let's get the right and left engine. Set float parameter. Connect both right and left engine to the target, and parameter name scale. Sorry, we need not float parameter, we need vector parameter. Set vector parameter. For me, I will change only the x value. Sorry, just 1 and 1. We'll change the length of the uh, multiply by 1, or I want it to be more than 1. The thrust value is the maximum 1 and the minimum is minus 0.5, so I will make it by 2, multiplied by 2. This name is scale. Now let's see. Press the throttle, the size increases, and if we decrease now, it becomes smaller. You can set the value whatever you want. Maybe 1.5 is better, I think. And now we need the engine sound. Let's set up the parameters here. Here what we need is continuous modulator. Let's call it speed, the parameter. Here and here speed. Now let's let's change the maximum input, maybe make it 10. Maximum output, make it also 10. Let's see. The volume, also we want the minimum input. If the minimum input is 0, so if the thrust value is 0, the engine will do not have any sound. And if it is, let's make it 10 here, maximum input, and maximum output make it 3, because this will increase the volume. So now let's test. Set float parameter. The float that we set was speed, and also in the thrust. And instead of, let me, maximum input is 1, and the maximum output 2, because we won't see any changes above 2. Also here maximum input is 1. We do not need to change anything in the blueprint. Now let's see. Now first, everything is 0. Increase. The volume, the minimum input, you do not want it to be admin input 0, and your output do not want it to be 0. Now I think the pitch we want it to, we do not want it to be 0 and 1.15 is better. And also I think we need to make it slower at increasing the value. Let me test it first. Let's use another filter to make it change the sound slow. Let's make another variable, call it sound or engine pitch level. We can't use the thrust value because it will change the thrust in the control of the airplane. So, sorry, where did I go? The bit world delta seconds, and the interrupt speed, let's make it maybe 0.2 to be slower at increasing and decreasing. I was trying to land the airplane. Now I think the sound is better. I need maybe a bigger runway. I think we're finished now. We have the airplane that can fly and has the sound and the particle system. If you want to implement the shooting, I think the shooting we made we can use the shooting that we made for the helicopter, the projectiles and the rockets, also the homing rockets. We can use them in this jet. I will provide the file of this jet project in the description. Thank you for watching. See you on another video.